Hello students, so today we are looking at our district benchmark performance task for the states of matter. Now we're going to be looking at the question today of how do changes in energy explain changes in particle motion? And we're going to be using this simulator here that I've got shown on the screen to be able to explain this. So what we see here is we see a simulation to where we are able to choose different materials from neon to argon to oxygen and to water. We were able to choose different states of matter from solid to liquid to gas. We are also able to change by adding heat or adding cool to remove heat from our system here. So please keep in mind that as we are going through. Now today we are going to start with oxygen. So as we look at oxygen, there are a couple things that we want to keep in mind. With oxygen in its solid state, I've clicked on solid here, we can see how the particles are moving, how the particle motion is inside of this simulator. We can also look right up here and we can see what the temperature is inside of the simulator. We can see here that a solid state of oxygen will be at 27 degrees Kelvin. Now I can change it to a liquid state of oxygen and we can see how the molecules are moving differently in a liquid compared to a solid. We can also see what the temperature is with oxygen at a solid state, being that oxygen will be at 57 degrees Kelvin at a solid state. We can also look at oxygen as in a gas state and see that oxygen will be at approximately 113 degrees Kelvin in its gas state. Now we can also start at one state, light liquid. We can add heat to that state and observe the changes within the states of matter as we add heat. So as the heat is being added, we can see the particles inside changing. We can see the particles inside acting different, doing different things. So remember that as you're doing the test. We can also, instead of adding heat, you can see we added up to 168 degrees Kelvin. We can also remove heat by adding cold, and we can see how removing heat also changes the particle motion. So keep in mind how the particles are moving differently as the heat is being changed, as the heat is being removed, as it is going from a gas to a liquid to a solid state of matter, and how those are looking differently. All right, you guys are going to do amazing on this district benchmark. All right, best of luck, you guys.